Right, so we'll get started today with our first chapter, which is Introduction to Quality Control. And this chapter is mainly designed to give you a quick introduction as to what quality is, how do we define quality, and what are some of the most important high-level methods of quality control. And this would give you a very good idea, hopefully, as to what you should expect throughout this course. All right, so let's get started with the definition of quality. Right, so here what I typically like to do is that I want you to stop for a minute and think about every possible context, or at least some of the possible context in which you might have thought about quality in your past, right? So maybe pause the video and ask yourself, how have you used quality? I really want you to think about how you would define quality. All right, I hope you got a chance to think about what quality means. And this is what I'm going to do. I'm going to write down a few phrases or few terms in which one can think about defining quality, right? So when you think about quality, you can think about the design. When you think about quality, you can think about precision. You can think about performance. You can think about reliability. You can think about safety. You can think about efficiency. Many times you can also think about the brand name. You can think about customer satisfaction. And of course, all of these, ways in which I'm defining quality really varies from applications to application. So I'm sure some of these definitions might align with what you are thinking. And in fact, you might be thinking much more than what I'm thinking right now. So you can see the definition of quality in some ways is not fixed. It depends on how we want to define quality or how we perceive quality, right? So this is basically what Garvin tried to do in 1987. Garvin came up with these 8 dimensions of quality and decided to somehow categorize quality, the definitions of quality, in these 8 different dimensions, which range from performance, reliability, durability, serviceability, aesthetics, features, perceived quality, and conformance to standards. Right? So these could be potential dimensions in which you can define quality. Now, in most of the contexts, when we define quality, we think about the product, right? But it doesn't have to be a product. It could also be a service. So when you're in the context of service, you can think about dimensions like how responsive the customer care agent were, or how professional they were, or how fast they were in resolving your concerns or issues, right? So you can again keep coming up with different dimensions of quality. So if I have to summarize, in short, we usually define quality in terms of its fitness for use, right? For instance, when we define fitness for use, for example, for a chair, um, a particular type of a chair from a particular manufacturer might be of high quality for some group of people, whereas might not be a good quality for some other groups of people. It really depends on the quality. It really depends on the fitness for use. But that's not going to help us in any way if we are planning to improve quality. If you're trying to improve quality, if we are trying to do quality control, then we must be able to measure quality, to quantify quality, right? And then fitness for use is not really quantification. You can't quantify quality by defining its fitness for use, right? So the modern definition of quality deviates from this traditional definition and says that quality, in fact, quality is inversely proportional to variability. Right now, it gives us some perspective as to how we can measure quality. So imagine, and I always use this example, imagine this Apple Pencil that I'm using right now to make my notes. If you were to observe variability, let's say just in terms of how long these Apple Pencils are lasting, if there is a significant variability in how long these Apple Pencils last, then you would start questioning the quality of these Apple Pencils, right? So variability is a very good way to define quality, right? Think about car, for instance. If a car, breaks down just after 10,000 miles or after 20,000 miles, if there's a lot of variability in when a particular car, a brand of a car is breaking down, then you might start to question that maybe the quality of this car is not great. So when we think about quality improvement now, we can think about somehow if we can reduce the variability, we can improve quality, right? So quality improvement basically means reducing the variability. Right? So now we know how to define quality. So whenever you think about quality next time, think about how much variability does it have, or your product or your service has. And then the lower the variability, the higher the quality. The higher the variability, the higher the variability, the lower the quality, and the lower the variability, the higher the quality. Okay. So now let's come back. Let's look at an example here. Let's say we're interested in buying bowls of average diameter 1.25 centimeters. And then we have three suppliers. Supplier A has a mean length of what exactly we're looking for. Supplier B has a different mean length, and supplier C also has the same mean length. Of course, I can take off supplier B because their mean length is different from our target. So now let's compare supplier A and supplier C. Now, if you take a moment and see, supplier C has bowls which are of varying lengths, right? So some are smaller, some are longer. Supplier A, on the other hand, wears very uniformly looking bowls, right? So I can say that supplier C has higher variability, higher variability, right? So if I have to pick supplier with the best quality, I would pick supplier A, right? Okay, so now we see how we can define quality. Now let's think about how we can actually control quality. And to control quality, we have to have an underlying process by which we are manufacturing something or processing something. So there has to be a process that we can control in order to control the quality. So now let's take a look at, let's try to understand what a process really looks like. And the process here could be anything. It could be as simple as making food, cooking your favorite uh, dish. It could be manufacturing a car. It could be operating on a patient. It could be, for instance, in the service industry, it could be solving customer complaints. It could be anything, right? But there's an underlying process here, and into this process, there are certain input factors. You know what? Let's actually define a process, and then let's try to work through that process. So think of an example in terms of manufacturing a car. Car manufacturing process. All right. So whenever you think about car manufacturing process, there's a bunch of input factors. Factors like the quality of the paint that you're going to use, the the metal or the material that you are going to choose for the chassis, or the engine, you know, or the electronics, or the leather seats, or the region in which you're going to manufacture them, the weather, the temperature, the vibrations inside your shop floor. All of these are input factors, right? And whenever you think of input factors, think of factors that you can control and think of factors that you cannot control. Right? So if you think of factors that you can control, let's call them as controllable factors. Controllable factors. In the case of car manufacturing, controllable factors could be, the materials that you can choose for your chassis, your seats, or your if there's any woodwork, bunch of things, your tires, several things. Think about the quality of paint. That is also an input factor. Think about engine. That's also an input factor. And all of these factors are by and large controllable. They are under our control. But there are also several uncontrollable factors. So uncontrollable factors. And one of the most common uncontrollable factors are vibrations. Wherever you are manufacturing or producing your car, you'll always have some type of vibrations. These vibrations are sometimes of such low amplitudes that we don't even recognize them, but they're always there. So if you have a very sensitive, high precision manufacturing process, that might be influenced by the vibrations in the nearby areas. Other potential factors could be the weather. It could be the temperature, and many more. Okay, so now we have controllable factors, factors that we can control. Uncontrollable factors are factors that we cannot control, are outside our control, right? So now you have a process, controllable factors, uncontrollable factors. Then once you manufacture your car, you're going to measure something that you can quantify. For instance, you can measure how long does it take for your car to go from 0 to 60. It's a good measure for the quality of the performance, for the performance of the car, right? Again, it can measure anything really that is of interest. It can measure multiple quality characteristics, which we talk towards the end of this course. All right, let's say you measure your quality characteristics and your quality characteristics do not match the target that you had, right? If you did not match the target, then you basically go back and modify the controllable factors, right? And then the process repeats basically. One thing that you have to keep in mind here is that when you think about a process, when you think about quality control in general, you always think about controllable factors because these are the factors that you can control. You cannot do anything with uncontrollable factors, right? So they will always be there. But whenever you think about quality control, always think about factors that you can control. All right, so now that we understand how to define quality, we understand what is a process. Now let's think about different methods of quality control. Now, on a very high level, there are usually three different methods of doing quality control: design of experiments, statistical process control, and acceptance sampling, right?